Hello, guys. Good evening to one and all. So, I hope you all are doing good. So, this is our very first series of data engineering interview live series. So, before we jump straight there, grab a coffee, come and sit relaxed, try to enjoy this session. If you have any doubts, please do drop a comment. So, I'll have a check and I'll try to give you the answer. So, before we jump to the video, who are we? We are Data Valley, the fastest growing edtech company of 2025. And myself, I'm Franklin. I have almost 3+ years of experience as a data engineer. You might be having a question, okay, we have a lot of data engineering interview series going across through the YouTube. How are you different in comparison to them all? So, my answer would be very simple. The answer is I'm a very practical guy, and these are the set of questions that I had to be asked during the interview. So it's not just from my experience, but it also from my friends' experience, whoever have been through the interviews regularly. So these the questions that come up in this series have been most widely asked, and who knows, when you attend the interview you might be surprised that, oh, I heard this question somewhere else. So this is going to be very in current, and these are happening in the industry. So you can trust this interview series. Do check up on us every day, because we telecast live videos most probably every day. And also, if you would like to check up us in different languages, we have Data Valley Telugu, we have Data Valley Tamil as well. So yep, that's it. That is all about us. So we'll jump straight to the content today. So today, what are we looking? So in the data engineering series one, today I have brought in you a four parts of section. So the first one is SQL questions. Next one is data modeling. The third session would be about the big data tools, and the fourth one would be about the ETL pipelines. So I'm bringing you bits and pieces of different concepts together, so that when you go for the data engineering interview, it'll be very helpful, rather than focusing on one technology or one concept at a time. We are going to have all at once, so that it'll give you a broad picture about how the data engineering world works. You might be a fresher, or you might be a pro coder or a pro data engineer, but do not worry, you might be preparing for your data engineering series now or in the future. So this is definitely going to brush up your skills. This is going to give you a better knowledge and understanding. So I hope this content will be very helpful. So we'll jump to our first question now. So in this SQL session, our first question is, how would you optimize a slow running SQL query? Okay, so we have a scenario where you run an SQL syntax or a SQL code, and now you assume, or you have a scenario where the code is running very slow, and the output or the result is taking a while to be seen in the screen. So how would you handle it? Let's be very practical rather than jumping to theory. So if it was me, the first thing I would do is I will index regularly used columns. What are the regularly used columns? For example, let's say I'm using a column customer ID. Okay, you all would have heard about tables and the column about the IDs. Okay, so customer ID would be a most commonly used column within a table, right? So if it was me, first I would index on that column, so that when you create an index, a pointer gets formed or created in your database. So instead of going through the full table scan, because you have index, these data can be accessed through the pointers from your database, therefore improving your performance. So the first strategy would be to index on the regularly used columns. Okay, second, I would avoid using select star. So if you all have been using database regularly, you know what a select star would do. So if you run select star, it would fetch all the column and all the data within it, right? So instead of doing it, because let's say I have a table which is of 1 GB in size, and if I fetch it, imagine it's going to have a full table scan, and it is going to give me the 1 GB of table, right? But let's say it has some unnecessary columns, like the timestamp when the data was ingested. Let's say you have a different column that says a description about the product. As a data engineer, you wouldn't be needing any description about the product, right? Because that is the duty of the business sales team to see and understand the description of a product. But for your case, you as a data engineer wouldn't need that information, or I would say you need that information, but it is not that important. So in case if your code is running slow, what you can do is, instead of using select star, you can specify the columns that you would like to use, right? So let's say I want to run a table that is of 1 GB in size. So instead of running all the columns or fetching all the columns, I would run select customer ID, product ID, the date, or whatever the necessary columns only. Okay. Jumping to our third point, filter early with where clause as close to raw data as possible. Okay. So what does a where clause do? Where clause is used to filter your data, right? For example, let's say let's say we are talking about the country India. So maybe India is divided into four divisions as north, south, east, and west. Let's say you are running a query about sales within a region. Okay, let's say the region is south. When you filter using a where clause, okay, so select the particular column from the table name, and when you add the syntax as where and the region to be south, so let's say in my 1 GB of table, each region is occupying 250 MB of data. So when I specify which region is it, so I'm minimizing the total quantity of data that is being processed, right? So when I give the where clause, it filters early, and instead of 1 GB scan, I'm running a 250 MB scan. So which is better? Is 1 GB better or 250 MB better in terms of processing? 250 MB would be faster, right? So try to use where clause as early as possible in your data so that you can avoid the full table scan. Next, use explain to identify bottlenecks. So what is this explain? So for example, let's say you have a simple code, select star from employee table, okay? When you add the clause explain in front of this code, okay, you will get to see how is this code getting running, how is this code getting processed, what does this code fetch, what is it joins within that query. Okay, so I've specified here. So when I use the term explain in front of my code, it is going to show me, am I scanning the full table, am I missing the indexes? Because for instance, let's say I've applied an index to a particular column, but for some reason my query hasn't picked it up. So it's going to show in my query that no, you're missing indexes. Okay, it could be some technical glitch, or sometimes it could be even humanly error, because it is possible, because you might have multiple tables and you might be assuming that you have added index to a particular column, but in reality it happens that we might miss it at times. So when you use the explain, you get to see if you have added the index or are you missing it. You might see the type of joins that is being utilized in your query. So I hope you all know that join is a costly operation. So what do I mean by costly operation? What do I mean by costly is that there is going to be a lot of data involved. So there is going to be a lot of data shuffling within, right? So the more data it shuffles, or the more the data gets merged, or more the data that gets queried from different table, it's going to make the process an expensive one, right? For example, let's say I have two tables of 1 GB each. When I run a join, it's going to be expensive because the table is in combination is going to be 2 GB of size, right? So make sure that you run the explain command, which will help you to understand if the joins are expensive. Then you can also see if you're doing some unnecessary sorts. At times, you might not be needing any order by clause to check, You don't have to sort it by anything, either ascending or descending. At times, because by natural, you might have your data sometimes ordered, so you don't have to do that. So you can check with the explain command. Talking about a next point, it says update table statistics using analyze in PostgreSQL or DBMS stats.gather table stats, which is an Oracle database, to help the optimizer. So what happens is whenever you give a query to your database, the optimizer within the database helps the query to choose the best plan for the execution. It tries to use your filters as early as possible. It might try to give you the best join possible for your data set, right? For the better performance of the database. So when you update the table statistics, so what do I mean by table statistics? So table statistics stores certain information like what is the row count, what are the distinct values within your data set, what is the max value, what is the minimum value of the particular column. So you might be able to access these kind of information with your table statistics. So when you update your table statistics, these informations get updated in your table statistics. Hence, the optimizer can choose the best plan for your query. The next one is denormalize if necessary for read heavy workloads. What do I mean by denormalize? It's a detailed explanation, but to give in a nutshell, denormalize is a process where you break down a larger table into smaller chunks. Oh, sorry. Denormalize is a process where you combine the smaller tables to a bigger one. So normalize is where you break down the bigger table, right? So normalize is where you break down the bigger table, and denormalize is where you combine the smaller tables to make one larger table. Okay. So denormalize if necessary for read heavy workloads. So what's happening is you're avoiding a join, right? Let's say I have three smaller tables, and if I'm joining them, and since join is an expensive process, it is going to cost your performance, right? So if you denormalize it and make it as a single big table, it is better for your read heavy workloads. I hope you all understood it. And then use CTEs for subqueries wisely. Avoid materializing unnecessarily. So what does CTE do? So CTE stands for Common Table Expression. And subqueries, where you run a select statement within a select statement or within a query. Okay, so that is what CTE and subquery stand for. So one benefit of using CTE and subquery is instead of materializing your data, you make a temporary data set or a temporary table or a temporary result for your existing data or the query that you're running. Okay, so when you have a temporary data or a temporary table, instead of storing it and instead of loading it again to the query, you're saving up a lot of space, and also you're saving up your performance. So these are the key things that I would do to optimize my slow running SQL query, right? I hope you all understood it. Jumping to our second question, write a SQL query to find the second highest salary in a table. Let me say this to you. This is one of the most asked questions in an interview. So how do you solve it? I will show you the technical implementation, but first let's dive deep into the theory to see how is the code actually getting run. Okay, let's split the code into different parts for your better understanding. Okay, So, can you take a guess of what this code can do? Select max of salary from employees. So, what does it do? So, you're having an employees table and you're having a column salary. When you run the max function, it fetches you the maximum value from the salary column, right? I hope it's very clear now. Okay, but the question that's being asked is find the second highest salary from your table. So, how are we going to do that? So, see here, we have select statement. We're selecting the max of salary as second highest, which is our alias. But do not worry, you can give any alias of your choice. It's not necessarily the second highest, but when you write it as second highest, it helps for the better readability, right? So that's why we have put the alias as second highest from employees, okay, which is our table again, where salary. So you're filtering based on the salary column, and now you're running a subquery which gives you the maximum salary, right? So let's put it this way. Let's say you have a series of number 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. What would you say is the highest of this series of number? It's 10, right? If you put that in the descending order, you would get to know that 10 is the highest of all the series of number. Okay, but my question here is fetch the second highest salary. So how am I going to do that? So here I'm selecting the max of salary and I'm using a where filter for the salary column, and I'm saying to the database that but I want one value lesser, or let's put it in simple English, I want the lesser value in comparison to my max of salary. So in our analogy, we had 10 as our highest value, right? So what is the lesser value in comparison to the 10? It is 9, right? So 9 is the least value in comparison to the 10th, but still it is our second highest or the maximum of the number, right? So that is how you find the second highest salary in your table. Let's see that in the practical implementation. So let's start fresh. I'm dropping my database. I'm creating a new database called data engineering. I'm using the database. Here is my DDL. So I have an employees table and it has few columns: ID, name, department, salary, status, and manager ID. So ID is my primary key with integer as the data type, and name has varchar. So varchar is where you can have variable number of characters. So I've set the maximum limit to 100, which is same for department and status as well, except that it can hold only up to 20 characters. So for salary, I've given decimal till the 10th of value with two dot notations, right? So this is how my employee table looks. I'm inserting few records into my employees table with few columns as null. I'm giving my status as active. I'm giving the salary column with variable numbers. I'm having my department. I'm having my name and ID. Okay, before we jump, let's see how this data looks in our actual table. Okay, select star from employees table. Okay, so if you run this, you get to see that you have few employees. It's very unordered, that's fine, and their salary is listed, right? 60,000, 55,000, 80,000, 70,000, whatever. So based on my understanding from this data, I assume 95,000 is our highest, and it is for the employee named Frank, right? Okay, so that is how our data looks, and let's run our query to check. So select max of salary as second highest from employees where salary is less than, select max of salary from employees table. Okay, So as you see here, it has given me the second highest, which is 90,000. What was the highest? 95,000. So if you check the table again, so we have 95,000, and the second least is by Eve, who is getting a salary of 90,000, right? So that's simple it is. So jumping to our next question, what's the difference between where and having clause in SQL? So what's the difference between where and having clause? So where filters your row before aggregation, having filters your rows for an aggregation. So that's the difference. Okay. So where will filter your rows before any aggregation or before any grouping. Okay, in simple terms. But having filters the aggregated results, which is given by group by again. Okay. So also note that both where and having clause can be used parallelly within a code. Okay, so it's not that you can use only where clause or having clause separately, but you can use both of them at the same time. I've given a simple query which we will see the technical implementation as well. So I have got your select star from employees where department is equal to sales. So I'm filtering based on the department for sales, right? So there is no aggregation happening here, or in other words, there is no group by clause in here, right? So let's see how the having clause works. If you see here, I have select department, then I'm running an aggregate function here. So count star is an aggregate function. I'm naming it as total employees. So total employees is my alias because I'm using the word keyword as. So count star as total employees from employees, group by department. And here, as you can see, I'm using my having clause for count star greater than 10. I think I have lesser data, so I'll just put maybe 2. So what's my goal here? So I want to group based on my department, and I want to check if each department has employees more than 2. Okay, so let's see how this runs in our code. As you see here, so first I would like to run my where clause. Okay, so this is our existing table. I'm filtering it based on my where clause, and I'm filtering it based on the department. And for which department am I doing it? It's for sales department. So when I run it, I could see that I'm selecting the employees from department sales, right? I'm just choosing the employees only from the department sales. So that is how you use your where clause. So no aggregation has happened, so you can filter it. Now with aggregation, I'm using an having clause. Let's see how this works. As you can see, I've grouped it based on the department, and I'm checking how many employees are for each department. So as you can see, it has grouped, and I'm running an having clause. So what does it do? So I've done the aggregation here, and I'm checking if there is more than two employees for each department. Now, as you can see here, it has given me two department names, that is sales and IT. And for sales, you have 5 employees, and for IT, you have 3 employees, right? So next to our key points, can we use where and having clause combined in our query? Yes, you can run it. So you can see I'm selecting the department. I'm running an aggregate function here. Average salary as average salary. So average salary is my alias, and as is my keyword. So I'm average salary is my aggregate function from employees table. So I'm using where clause here, and I'm saying that where status is equal to active. So say status is my column, right? So I'm filtering it early, and then I'm grouping it based on the department. And then for the department, I'm running and having clause which uses the aggregate value and I'm checking if the salary is above 50,000. Let's see what this code gives us now. So as you can see here, it has grouped based on the department, right? So we had three departments in our table: the sales, HR, and IT department. And then we can see the average salary, which is our aggregate function. And I've also said that I need only the salary of department above 50,000. Okay, this is huge number, so maybe let's round it up for better understanding. So as you can see now, the average salary for sales department is 57,500. For HR department, it's 75,000, and for IT, it is 81,667. So I hope the concepts are very clear to you. Where is used before aggregation. Having is used during aggregation. Okay, so aggregation in the sense you use group by clause, and also you have to remember that both having and query can be used parallelly within your code. Okay, jumping to our fourth question: how do you typically handle null values in your SQL queries? Okay, as a data engineer, it is your duty, and this is one of the most commonly faced problems within the data. Okay, you might get the data that has null value within it, so you must make sure that you understand this concept well. So before we jump how to handle it, do you know what is null? So what is null? Is it zero, or is it some value, or what do you think null value is? So feel free to drop a comment, but I'll give you a short description of what is null. Null basically means no value. It doesn't mean there is a value called zero. Why did I say value zero? The reason is simple: because zero is still a number. It gives some kind of information, but null is just blank. You have no data at all, right? For example, let's say, how many eggs did Franklin purchase today? And your answer is zero. So, zero, you're giving me some answer, you're giving me some information. But rather, let's say, how many eggs did Franklin purchase? And you haven't given me any information. So this will make sure our data is not complete. It will hinder our data integrity, right? So you have to make sure that this null values are handled well in your SQL query. So this is how you should handle the null values in your SQL queries. First, detect, do you have any null value within your data? So whatever the tables that you have, whatever the data is within the table, first you have to check, do we have null value at all in your table? So how can we do that? So you have to select whatever the columns that you need from the employees table, and in the where statement, I'm using the manager ID to check if there is any null value in my data set. Okay, so first, what should you do? You should detect using is null function. So I'm checking if any of my manager ID is null. Okay. And next, okay, I have found some missing data, which is good. So how do you handle it now? There are different scenarios how you handle null values within a data engineering sector, but let's not dive deep into it today, but rather focus more towards the SQL kind of handling it. Okay. So here I have my select statement with name column and coalesce function. So what does this coalesce function do? So coalesce function is, if there are any null values, it replaces with a new value or the value that you're providing. Okay, let's say you have a manager ID 1. Okay, because it has a value, it will not take this value, right? So if there is a first value in this first position, the new value will not be getting added. But in other scenario, let's say your manager ID column is having a null value there. So in that case, it gets replaced with a value that we provide. In this scenario, I have given as not provider, right? And also I have given the alias as manager ID, and this is running in our table employees. So let's see how is this done in our technical implementation. So first let's see how our employees table is. So you have your employees table with the columns as you can see: ID, name, department, salary, status, and manager ID. And you can see that there are few null values. So who are having null values? Carol is having a null manager ID. Frank is not having a manager ID. And Heidi is not having manager ID. Okay. So as I said first, we have to find if we have null values, right? So I'm giving null filter for our where clause, so which will give us only the columns or the data with null values. So as you can see, Carol, Frank, and Heidi are having null values for their manager ID. Okay, you have found it. Now how do you handle it? So we use qualis function to handle null. Okay, so when I run this command, can you see what I've done here? So yes, the other managers had a manager ID. Alice had a manager ID, Bob had a manager ID, but Carol, Frank, and Heidi didn't have a manager ID. So I'm replacing it with not provider, and hence, as you can see in the data below, we have replaced it with not provider. Right? Simple. So I hope you all understand. So how do you handle null value? First, you detect if we have any null values, and then you replace it using a null. Then you replace the null value with some business scenario useful values, right? For instance, you can put not provider, or there are other ways you can replace those values. For example, let's say you have a numeric value. Okay, for example, salary, for example, the transaction, for example, you have a price column. So what you can do is you can use business logic, and you can apply either average function, or you can either give a median value for your numerical data. For categorical values, you can add values like unknown, not provider, or you can use the most widely used data within your data set. For example, let's say the most repeated the value within my categorical value is the manager ID 2. So instead of not provider, what I can do is I can give a value here as 2. Okay, but it all depends on your business use case, what is being asked of you to do. Okay, so make sure you detect the null value, you replace it with qualis function depending on the business case. So for numerical values you handle it differently, and for categorical values you handle it differently. Jumping to our next session, the data modeling session. So what is data modeling in simple terms? So data modeling is how you design your database, your table, or how you structure your data set, or how you structure your data. And for example, you create tables and then you create relationship within each of these data set to make it relational, right? So these are the concepts within data modeling. In other words, you model a database, you model the existing data, or you model how the data must interact between the table. Okay, so that is the data modeling. So before we jump to normalization, do you remember what I said about denormalized, which we saw in the very first question of how to handle the slow running query? So normalization is where you break a larger table to smaller chunks, and denormalization is where you merge the smaller tables to a one big table, right? So, coming back to our session of modeling, what is normalization? Normalization is the process of organizing data to reduce redundancy and improve data integrity. You might be wondering what is redundancy. Redundancy is something where the value or the data gets repeated again and again. The more the data gets repeated again and again, it is going to cost you your storage, your processing speed, your query speed, the way the data loads within the query. So it's going to be a tedious process or a long run process when you run the similar data again and again, right? So your goal is to reduce redundancy. We will see how that is done. And it mainly emphasizes to improve your data integrity. So in normalization, you have three normal forms. Okay, the first normal form, the second normal form, the third normal form. What does each normal form do? In the first normal form, you make sure there is only one atomic value within a table for each column. What do I mean by atomic values? So atomic values is something where you don't have list of values, but rather just one value. Okay? For example, a person named Franklin, he is giving a phone number. Okay? Instead of having two different phone numbers within a single column, what I can do is I can make a new row for the same customer Franklin, and I can add the phone number separately as a new row. So that's how the first normal form is. For example, you can take our scenario here. So I have an unnormalized table here which stores the customer information. As you can see, I have customer ID column, the name and phone numbers. And for the customer John Doe, you can see that he has two phone numbers, right? So how can I convert this to the first normal form? What I can do is I can split the phone number into two separate rows. So for the same customer ID 11 and for the same customer name John Doe, I've created two separate rows for each different phone number. So this is how you do your first normal form. So what is second normal form? So second normal form is when you don't have partial dependency. What do I mean by partial dependency? So partial dependency is when your non-key attributes doesn't depend on the primary key. Okay? So there should not be any partial dependency. Okay? If part of the primary key determines some attributes but not all, those attributes are moved to a separate table. For example, let's consider our scenario below. I have an unnormalized table here which has the orders and the product information. So as you can see, you have order ID, product name, and price. So for order ID 1 and 1, I have two different products. I mean product ID 101 and 102. And for 101, the product name is laptop, and for 102 product ID, the product is mouse. And as you can see here, product ID 101 again has laptop in here, right? So laptop is repeating again and again. Let's say you have 100 columns. 100 rows. When you have a repeated product ID, you're going to have a repeated product name again and again within your data, within your table, right? And to make it worse, you can see the price column, which shows your laptop's price, which is 800 pounds, which shows your cost of mouse, which is 20. So imagine if more sets of columns get repeated again and again with the product name and the price. It is going to cost you your storage, right? With the same data, that's the worst thing. It's okay to fill storage with suitable or the useful or the necessary information. But in this scenario, it's unwanted data that is just getting redundant within our table. So what do we do? In our scenario here, order ID and product ID is our composite primary key. So what is the definition that I gave? There should not be no partial dependency. So non-key attributes must depend fully on primary key, right? So what I'm going to do here is I'm splitting the table into two different tables. The one is orders table and the other one is products table. So orders table has the order ID and the product ID. So order ID 1, product ID is 101. Order ID 1 has another product 102. Order ID number 2 has the same product ID as number 1, which is 101. But instead of redundant values as laptop, mouse, 820, which is the price, I've created a new table. So this is going to have all the information, or let's say it's a product catalog. So what is the product ID for laptop? It's 101. What is the product ID for mouse? It's 102. So rather than repeating, I'm having just a value and I'm storing that as an integer within our orders table. And also as a general information, the varchar or characters or the alphabets within your table will cost you more space. But rather if you use integer, it's going to reduce your storage size. So it is always recommended to use numerical data within your tables as much as possible. Okay, jumping to our third normal form. What is the third normal form? You have attained the third normal form when you do not have any transitive dependency. What do I mean by transitive dependency? So transitive dependency happens when a non-key attribute depends on a non-key attribute. What do I mean again? So let's say I have a non-key attribute. For instance, in our scenario, we have department and location. Okay, these are non-key attributes. What is our key attribute in this one? Employee ID and employee name, right? But department and location are non-key attributes. Okay, in this scenario, we have a table of employee information which stores the department and department location as well. So how can we achieve third normal form for this? We can split the table into two different tables. One for employees and the other for the department, right? So employee ID and John Doe is working for the marketing department. And as you can see here, the marketing department is based only on New York. The sales department is based within Chicago. The marketing department is again based in New York. So let's say you have, both the columns repeating again and again. It doesn't make any, valuable information to the business, right? So what we can do is we can assign an integer value to this. We can assign an ID to your department to make your data or your query optimized. So see here, I've assigned a department ID. So marketing department has the department ID 1 and sales department has department ID 2. So if I put that in the employees table, I'm having the employee ID, employee name and department ID. So I'm just stating what department ID John Doe is from. What department is Jane Smith from? What department ID does Bob Johnson have? So the departments table has the information about what is the department ID, the department name, and the location. So that is how you split into the third normal form from your second normal form. Okay. So I will give a bit of a summary. So first normal form is where you don't have a list of values, but rather an atomic value. So we split any row or any field that has two values, you split that into two. Okay, that is for the first normal form. And second normal form is where you don't have a partial dependency. Okay, So all the non-key attributes must depend fully on the primary key. Okay. And what you do for the third normal form is where you don't have transitive dependency. What is transitive dependency? Where one non-key attribute depends on another non-key attribute. So that is how you remove the third normal form. Jumping to our next question. How would you explain the difference between a star schema and a snowflake schema? So, star schema and snowflake schema is well known, used within the data warehouse setup. Okay, so in most of the data warehouse projects, these are the schema that is being followed. But depending on the different business use case, there'll be an instance for you to choose: should you follow star schema or should you follow snowflake schema? So what is star schema? Star schema is a denormalized dimension. What is denormalized? So denormalized is where you combine smaller tables into a one big chunk, right? One bigger table. So in star schema, you have denormalized dimensional tables. And fact tables is mostly of numerical data, and a dimension table mostly stores the referential data. So when you do the denormalized form, your query becomes faster because the joins that you have performed will become lesser, right? So let's say in other, we'll go through that, but we'll go through the snowflake schema. But let's say, imagine this picture. By seeing this picture, what do you understand? You have lesser dimension table in comparison to the snowflake schema, right? So lesser the dimension table, lower the joins that you're going to use, which in turn will improve your query performance. So as you can see, you're doing simpler joins. Let's say you have to run here, you have here almost like 12 tables. So for the fact table, if you run 12 joins, that is a costly operation, right? But see here in the star schema, you have only roughly 4 tables. So if you run joins with this 4 table, you have lesser joins, which in turn will improve your query performance. It's ideal for OLAP, which is for analytical purpose. In Snowflake schema, you can see that the larger tables are broken into smaller chunks. So it's a normalized dimension table. It reduces storage redundancy. So what does a normalized form do? It reduces your data redundancy, right? So it is going to save your storage cost. It is better for write efficiency. So talking about write, it's mostly to do with the OLTP, which is a transaction service. And also, because you're normalizing it, your data integrity will be better. Okay, though it has more complex joins to do, these are the advantages that you get with the snowflake schema. In short, the benefit of star schema is it's better for read performance, so mostly for OLAP use cases or for the data warehouse setup. Snowflake schema is better for the storage and maintenance, and it is better for OLTP based service, and OLTP is most to do with transactions, so it is mainly this is how you design your databases. Jumping to our third question, imagine you are designing a data warehouse for a banking system. How would you approach it? So we are not going to design exactly a warehouse for a banking system, but rather we are just checking on how would you approach it. So what are the steps you would follow to design a data warehouse for your banking system? So these are the simple strategies that you can use, not only for banking system. Let's say you have a financial company. So how would you design it? Let's say you have an healthcare company. So how would you design it for them? So these are the basic approaches that you must follow. First of all, try to understand the business requirement. What is the purpose of your business? What are you trying to handle? What is the type of data that you're trying to use in this system? Are you going to store transactions? Are you going to deal with compliance data? Are you going to find some patterns to detect frauds? Or are you going to use it for customer analytics? What is the business requirement? Try to understand the business requirement first. Then Depending on the business requirement, start designing your facts and dimension table. Once you understand your facts and dimension table, then you must see how are you going to implement your SCD. So what does SCD stand for? It's slowly changing dimension. So when the new data comes in, the dimension tables get altered, right? So let's say I had 5 records today, and tomorrow I'm getting 5 more new data, and also I have 3 updates for my existing data. So how would you handle it? So what is your business requirement? Does it say you don't need to maintain history but just updates the existing record? Or does it say that, oh, you need to have all the historical data as well with the schema version? So that would be type 2. Maybe your business says, don't worry about maintaining all the history. Our main goal is to save some storage and memory. So what you can do is you can have the partial history. So it just stores one new value or the updated value and one previous column. Let's say I had one update today and second update tomorrow. So it is going to have the new value and yesterday's value. And now let's say I'm doing my third update on the day after tomorrow. So instead of having my first update or the first value, it would rather delete it and just have my second day's value and my third day's value, which is my day after tomorrow's value and tomorrow's value, right? So that is how you design your SCD. So for the historical data, you can bulk load it, and then you can use change data capture for incremental update. Let's say I have a business setup where they are having almost like 3 years of data, the historical data. So I can first do the bulk load or initial load. So where I load all the 3 years of data straight away. So after that, how am I implementing my CDC? So CD is the new changes. So change data capture. So you're going to capture the changes in the data. Okay. So with all the incremental update that's happening, how are you handling this CDC? And then, so how are you securing your data? Are we, are we compliant enough? Are we, following the governance policies? So make sure that your storage or all your data is encrypted properly. It's all about security and audit and how secure you store and transmit the data. So this is how you should plan your next step. So the tools are just common. You can use any tools depending on the business requirement. Sometimes they might say use legacy based system. They might say that use cloud based tools, or they just might say that we never want any option for you know uh, the legacy based, just go for only cloud based tools. So it depends on what kind of tools the business requires. Jumping to our third session, the big data tools. How would you compare Spark and Hadoop in terms of architecture and use case? Talking about the architecture, Hadoop is more to do with the Hadoop MapReduce. It's a complete framework. But and in terms of Spark, the the core is Spark, okay, which is RDD, and then on top you also have different setups like Spark SQL, mlib, Spark streaming. So this is how. So Hadoop is Hadoop framework. So for Hadoop, it is Hadoop MapReduce, and for Spark, it is multiple core frameworks like Spark Core RDD, Spark SQL, and mlib streaming, etc. How does Hadoop process it? It's batch processing. How does Spark process your data? It can have batch data. It can do real time processing, and then also important key factor is it is memory based. So Hadoop is disk based, and Spark is in memory processing. What do I mean by in memory processing? The data gets stored to the in memory. Lazy evaluation happens, so the data remains within your memory, and once your result is out, and that is when your data is finally loaded into your disk. So all the intermediate data, it gets loaded to your memory, therefore your query runs faster. So because it's disk based, each time the query runs, it takes the data out. The intermediate results are again put to the disk. Again, it fetches the data to the disk, to the memory, it processes it, and again it drops the intermediate value to the disk. So therefore it's slower. But rather in Spark it is just in memory. Hadoop map produce code is very hard to write, but Spark it is very easy to use because it supports multiple APIs like Python, Scala, Java, or fault tolerant. Both are fault tolerant. Data storage is HDFS, which is Hadoop distributed file system. But Spark is a framework on top of Hadoop. Okay, instead of Hadoop, it can have multiple different storage. But because we are just talking about Hadoop and Spark, Hadoop is HDFS and Spark users can use. Okay, it's not just uses HDFS. It can use HDFS S3, which is a storage service from AWS. It can use Cassandra. So that is how Spark operates the data from the storage. Talking about scalability, both are highly scalable. Does it support streaming? No, Hadoop doesn't support streaming as efficient as Spark, because in Spark it is natively present. So via Spark streaming or structured streaming, you can do streaming as well. Okay, you can use stream data as well. Machine learning, it needs external integration for Hadoop, but in Spark it has an inbuilt framework called mlib. It is best for traditional batch ETL, and Spark is best for real-time analytics, and it also supports multiple machine learning because it has mlib, and it helps in faster ETL transformations and construction as well. So talking about the use case, let's say you have large-scale batch processing. Okay, go for Hadoop. Let's say you have real-time data streaming. Hadoop has limited feature, so you can use Spark. I have iterative machine learning process to be done. Okay, Spark supports it natively, which is Spark mlib. I have long-running ETL jobs, so go for Hadoop. I'm having data science and exploration scenario. I can use Spark. Okay, because Spark code can be run with Python or and these have better APIs as well. Can you explain how partitioning works in Apache Spark? Okay, this is how the data is partitioned within the Apache Spark. First, when you partition the data get distributed to multiple executors and nodes for better parallelism. The more the data gets distributed, it's for better parallelism, right? So the data gets distributed to the each executor and node, and it is done. The partition is done by using hashing or range partitioning. Hashing is when you assign the hash value, and range is when you assign range values for each of these. Okay, so you give a range value, for example, like 1 to 5, and I have a data. So I assign 5 partition. So my data gets assigned to each of this partition. Okay, so the range is 1 to 5. So it gets assigned 1, 2, 3, 4, 5. For each range, it gets assigned accordingly. So one key consideration is I have to use partition key wisely with low or medium cardinality. What do I mean by this? Let's talk about our previous scenario where we talk about the regions, the north, south, east, and west. So you can assign your partition very easy depending on the partition key, right? So when you partition based on this, your 4 cardinalities are going to be north, south, east, and west. It is easier. But let's say you have high cardinality. Let's say your customer ID is your partition key. In that scenario, the data is going to distribute it massively, and it doesn't benefit our benefit our use case. Use partition, repartition, or coalesce wisely. So repartition, you have to use it only when it's shuffle heavy. So let's say you're increasing your partition size from 4 to 5. In that case, you can use repartition. But let's say you're reducing your partition size. In that case, you can use coalesce. Okay. And one more benefit is it enables predicate pushdown and partition pruning. What is predicate pushdown? So predicate pushdown is where you filter your data earlier, and then when you try to fetch the data based on the partition, only the required data gets fetched, or the required data gets pruned instead of the full table scan. Okay. Next one is, why might you choose Parquet over CSV for storing large data sets? Okay. Parquet is a columnar data. Okay. Columnar data format. So it is better. It provides better performance. It supports schema evolution. Okay. But rather, uh, in CSV you don't get support for the schema evolution. Okay. So Parquet is a columnar data format, and it also supports our schema evolution. It provides efficient input and output. Okay. Because it's columnar, the data gets compressed better. Okay. So you can compress it using Snappy or gzip. Because your data is compressed and your data quantity becomes lesser. Okay. It's compressed. Okay. Let's say you have a 100 MB file, and because you have compressed, your data becomes like 20 MB file or 30 MB file. So lesser the data, it gives you efficient IO, right? So it gives you better input and output ratio to be a better value. So that's how Parquet helps you. And this is ideal for analytics. Okay, example, in data warehouse setup, you store your file in Parquet format. Talking about CSV, it is row based. Because it is row based, you're going to save the data. No, you're not going to save the data, but rather you're going to cost a lot of storage. Okay, which the companies wouldn't prefer, or your business scenarios wouldn't prefer. So try to use columnar based, which will help you with better storage. The schema evolution support is no. So you don't have schema support at all in your CSV, and you don't have compression as well. For large data set, it is very inefficient. So because there is no compression, you can't compress a large data set, right? So let's say I have a large data set of 1 GB file. So if I compress it using Parquet, Snappy and gzip, it is going to be around 300 MB. But because there is no compression within the CSV, we are going to save the 1 GB data file as it is. So you're not going to get efficient IO, you're not going to have better storage, and it is going to cost you as well, right? So you need to, as a business person or a data engineering person, you must consider the cost as well. You must optimize the cost. So make sure that you prefer or you use Parquet file over CSV. And one key thing about Parquet is, as I said before, it supports schema evolution. So what is schema evolution? Let's say I have 3 columns of data today, and tomorrow I'm having one extra column coming from my database. CSV doesn't support it, but rather in Parquet, you can either store it as null value, or you can have the data itself depending on how you provide the code and how you are trying to process the data. Okay, so there is a support for schema evolution. No matter what, the data evolves periodically. You can make sure that your data can be stored properly. Okay, considering our time today, we will talk about the ETL pipelines in our next session. But do regularly check on us, because as you can see here, I have plenty of data engineering content coming for you. Okay, so do follow us. If you like this content, do drop a like. If you if you have any questions, also drop a comment. Feel free to share it with your friends who are aspiring to become data engineers as well. So this is Data Valley, one of the fastest growing edtech company of 2025, and we have our headquarters in United Kingdom, USA, and Hyderabad as well. So follow us for more interesting content, not just data engineering. We have multiple sectors as well. like data science, we have ethical hacking, MERN stack, you have UI and UX, ethical hacking, Java, Python. So you have different, you know, kind of learning within our institute. So hope you all enjoyed it. Do follow us. Thank you for attending this session. Thank you so much. We'll see you in the next session. Until then, this is Franklin signing off. Thank you so much.